Hi everyone. This series of videos is intended to introduce the Analog Discovery Board and the waveforms software. I'm Professor Ram from the Engineering Department at UMass Boston, and I also run the Ubiquitous Communications and Networking Lab, or UCAN Lab. You might be watching these videos in preparation for a course that will use these tools, or maybe because you're interested in the Analog Discovery Board as a hobbyist. Either way, I hope that these videos are useful to you and that the information that you get here will help to build a foundation for using these tools in future projects. In this first video, we will introduce some terminology and motivation for the tools, and then we'll take a first look at the Analog Discovery Board itself. Let's start with a bit about why we are interested in these tools. First off, as electrical and computer engineers, we are often interested in signals. This includes generating signals and observing or acquiring signals. The essential tools that we need for high-speed signal generation and acquisition are the function generator, or more broadly, the arbitrary waveform generator, and the oscilloscope. Typically speaking, this equipment is often very expensive, hundreds or thousands of dollars each, and even more for higher resolution equipment. The Analog Discovery 2 is essentially a signal generation and acquisition board without a direct user interface. Instead, it plugs directly into your computer and runs software on your computer in order to view the signals and interact with the hardware. This makes the AD2 much more reasonably priced and also makes it more portable, allowing students to take the equipment home and work on projects outside of the typical lab environment. The AD2 also has digital input and output pins, a programmable power supply, and other additional functionality. When we use the Analog Discovery Board, we want to keep in mind the distinction between our hardware and what software we are using to interact with that hardware. In particular, the Analog Discovery 2, or AD2, is essentially the interface between the analog signals or circuits that you might want to interact with in the physical world and the digitized signals that your computer can actually manipulate. In order to control the hardware and generate or observe the digital signals on your computer, we utilize a software that communicates with the hardware and processes the raw data that goes to or from the hardware. We will mostly focus on the waveform software by Digilent that offers a simple graphical interface to generate, observe, and manipulate the digital signals and also to interact with the hardware. Keeping in mind this distinction between our hardware and the software, other software options are also available to interact with the AD2 board. This includes MATLAB or Simulink for MathWorks, LabVIEW by National Instruments, or other software tools. As we introduce the AD2, let's first look at what's inside the box. This image shows the contents of the box, with the primary piece being the AD2 board itself. We will discuss how to use the AD2 board in the next few videos, but you can also take a look at analogdiscovery.com in order to find the AD2 hardware specifications and some more information about where various components sit on the actual hardware. For example, where our pinout connectors are, the onboard FPGA, and various other components. Now, if we open up the actual box and take a look here, we can see that the Analog Discovery 2, or the AD2 board itself, is obviously the first thing that we notice. Digging a little bit deeper, we'll find a 30-pin fly-wire connector that allows us to connect the various input and output components of the AD2 board with a breadboard or other physical system. We'll discuss what specific wires connect to in a later video, but for now you can attach the connector right to the board, making sure to pay attention to where that notch aligns. And making sure to get a good, solid connection. The next thing that we take out of the box is our USB to micro USB cable. This connects the other side of our AD2 board, the other side of our AD2 board, correctly like we see here. And our other side is our USB connection that connects right to our computer. Lastly, in our box, we'll find a small bag with our ferrite bead snap-on connector and some 6-pin male headers. The ferrite bead snap-on connector can connect to your USB cable to suppress any high-frequency noise, and our 6-pin connectors, like we have on the breadboard here, can be used to nicely connect our analog discovery cables, the female side, to our breadboard or other connections. This summarizes our AD2 hardware, and in the next few videos we'll look into using the waveform software to actually control and interact with this hardware, along with a few of the most relevant capabilities of the hardware and software combination.